Hello viewers, welcome to my show Rocket Monday. In today's episode we're gonna take a look at space stations. So let's dive right into it. So what it is, it's a basically upgraded version of a rocket. Basically rocket allows you to go to space, this allows you to stay in space. It's a basically permanent settlement in space. Now permanent is relative compared to rocket. It's not permanent compared to a building or compared to a city. It's permanent in terms of a rocket. Like comparison is against a rocket. Rocket will remain in orbit for best case scenario like 8 days or 10 days. This can stay up there for years. Now generally they try to make it as self-sufficient as possible, as in it should not need things from earth to run, but generally they have very little or to no self-sufficiency. In terms of our space station, you can recycle the water, recycle the air, but you cannot recycle the food. And it's generally built close enough to any celestial body. It's never created in such a way that it is completely out of touch with everything, as in like you will not put it in a Lagrange point from of Mars or things of that nature. It has to be close enough so it can be supplied quickly, because I already mentioned they don't have self-reliance. Now generally the crew size that we are talking about, practically realistically speaking, it starts from 3, goes upwards of 14 and 15. So small kind of crew, like Russian capsules generally take 3 and shuttle can take more. So this is the idea of it. Then why the heck we take it? If it's not that magical, if we can't live there permanently, if it does not have self-sufficiency, why the heck do we bother with this? One simple reason: we have to understand effect of 0G on human body. Basically, what does space itself do to you once you are outside of Earth? So there is no alternative for that. You have to go there. Like no amount of R&D would have taught us that people cannot sleep in space properly, simply because if they close their eyes, cosmic radiation that is going by simply will interact with their retina and give them flashes of light. And it was it happened in moon mission also, but because there were only 3 people who were experiencing that, they simply decided to not talk about it, because like it sounded crazy. It's like, when I'm closing my eyes, I'm seeing basically stars. But enough people in ISS started to complain about it, then this became apparent. And you can't shield against cosmic radiation basically. So unless we had gone there, we had no idea of this. So we need to know, we need to have like hands-on experience about this. Now it's not a scientific challenge. It's not like science is telling you can't do this, but it is an engineering challenge. Like scientists did their job, they will tell you what to do. Now engineers have to figure out how to build it. So it is an engineering challenge on a level that humanity must master before becoming a spacefaring civilization. And it's a very simple, if you want to do anything serious or practical in space in long term, you have to have this as a stepping stone. This will teach you a lot. And in space, when people like astronauts that went to the moon, they did not stay there for long. Like there is a cumulative effect of radiation, cumulative effect of cosmic radiations and zero gravity that you can only study once you allow somebody to stand there for very long time, as in more than a year. So this is what happens once you come back from zero gravity. You can't walk on Earth, and your heart actually becomes more like a sphere, simply because gravity is not keeping in shape. People lose their eye, as in like eyesight worse. It does not go that bad that you will go blind, but you will lose basically precision of your eyes and other things also. But we have to be there in order to study it. There is no way around it. You have to be there to study it. So far nobody has figured out how do we have sex in space, and I'm quite confused by that. It's like you already have a permanent habitat, you already know you cannot sleep. Have sex, like figure things out. Like why? Like, do you want humanity to become a spacefaring? Because if we truly want to do that, somebody has to figure out what kind of dynamics happen in that. Now childbirth is also easier to test here, simply because if things go wrong, the nearest station is like just few minutes below, not like 2 years. So in case of a Mars, or 3 days in case of moon. So people have to do that here. I have no idea why they are not doing it. Now before we talk about space stations, we have to talk about Mir space station, because this is the fundamental space station that changed everything. Now many of you are familiar, during the space era everybody kind of accepted that Soviet Unions were ahead. It's just that their politics got better of them. So why do people say that? Even though they lost the space race, why the heck people say that? Simply because they figured this out. This was the first modular space station, and this happened after basically moon mission. So under no circumstances Soviet Union was beat, but at that time they were going bankrupt, so Soviet Union was dissolved. Russia took over this space program, and it operated from 1986 to 2001. And the fact about this is, like, it worked. Like, it wasn't pretty, it wasn't like, very pleasant to be stay in there, but it worked. Nobody died on it, and it stayed there, did its mission, and they targeted it for 15-year stay, but it did upwards of 12.5 years, not 15 whole years. Like, they had to abandon it afterwards, because, like, this was the first time, like, we didn't had any idea how the heck things will work out. So this was the first time we figured out how do we actually build a space station in space. So what about ISS? Now, many of you are familiar with the fact that ISS was a multinational collaboration. No single country can afford to build something this massive. Not America, not Russia, not China. Nobody can do this. To pull this off, like, there were two big partners, that's in Russia and America. Then budgetary help was done by European Union. Then some extra help was done by other countries, like primary being Japan. So this taught humanity how to work together, not trying to kill each other, how to work in sync and make sure all the things work with each other, because many modules are from different places. Like, one module is from European Union, another module is from America, another module is from Russia, another module is from Japan. How do you make sure these things work together without exploding? So it was a very good exercise in humanities to, like, actually come together and figure something out. Now, be mindful, it is multiple times bigger than Mir space station, and that's why I'm giving you that space shuttle as a comparison. So the pressurized volume in this puppy is quite huge. Now, compared to Mir, it's not multiple times. Don't expect it to be like 50 times bigger than Mir. It's only a few times bigger than that, and it's always manned. Now, this is crucial. International Space Station, barring any accident, generally is always manned. And what I'm saying about barring accident is that recent Soviet mission failed. The crews were ejected. So in those sort of scenarios, there is a probability if the next mission cannot be done within the operational window, ISS can be abandoned. Now, that can be bad, but that would be the only time since its inception that it would be completely unmanned. Is generally there is always somebody here, sometimes 3 people, sometimes 5 people, sometimes 7 people, but 24/7 somebody is always there maintaining it, doing research and projects of that nature. Now, people hated International Space Station, and I want to give you a very simple context of it. The reason for that is basically Mir space station taught us almost half of what we know about long-term stay in zero gravity. So we figured it out that we're gonna die. That's the only thing we figured it out, like, we're gonna die. And the amount of money America spent doing this was more than enough to build Large Hadron Collider in America, which they already started to build, which they already were gonna make, which was bigger than what we have, as in LHC, Large Hadron Collider, that is in operation today. They already dug the tunnel which was bigger than LHC. So the funding was cut from LHC, basically Hadron Collider that America could have built, to this. So many scientists kind of got pissed off about it, and it makes sense. So, and about research here, well, it only gave out one thing, that people gonna die in zero gravity. That's the only thing it practically taught us. And all this idea that we can do space manufacturing, nothing in 20 years has come out like that is, you can say tangibly, okay, this is worth doing in space. Only thing that recently came out, as in when I'm talking about recently, as in barely 2-3 years ago, and it's still being in development phase, is that we can make optical fiber which does not have crystals in it. So that way, that optical fiber is very advanced. To give you a context, it's like comparing earth-based optical fiber that is manufactured on earth. It's like a horse cart compared to what is made on ISS. Like 1.6 kilometer was made using 3D printer in space. That can transmit much more data. That would be like comparing Ferrari to a horse cart. So that's the only thing tangibly we figured out. Now, was it justified to spend like $400 billion to figure that out? No. And there is a lot of bureaucracy involved into this, so it's just not very efficient. That's why many people don't like ISS, because physics wise it did not teach us new things, which Large Hadron Collider did teach us, and in terms of space it only gave us little bit of improvement. It's not like a moon program where every day new research is happening. This is like we're gonna polish it a little better, that and this. It's not giving us like $400 billion went inside and $500 billion came out. It's like 400, and yeah, we may next 10 years start to use optical fiber that is made in space. It does have tangible benefit, but it's not justifiable. So that's why many people hate ISS. So what we can expect in the future? Now, first, in the future, the biggest space station that is right now, nearing completion is LOB-G. You can check my video here. And LOB-G is basically, instead of being in low Earth orbit, it's gonna be on lunar orbit. Basically, it's gonna be spinning around moon. You can check that video for further description. Be mindful, this will not be 24/7 manned. They are not targeting that for this. So people will come there to study long-term. Long-term stay is in this context is only for a few days to few months. Don't expect that to be 24/7 manned. So that's the LOB-G. So you might be like, okay, isn't LOB-G smaller than ISS? Yes, very small, and it's not spinning also. So that's why like LOB-G is also, people are like, why? Just directly go to the moon and check that video for further detail. It's just that it's not as good as it should be. Then we talk about the only another candidate country-wise that is trying to build something is China, which is building its large modular space station. Now that many rumors are coming out that it will be bigger than that, but practically speaking it can't be. No single country can afford that. Nothing. Like you might have to divert whole of your GDP to make that possible. So practically speaking they can't do that. And it is China, so the information on this is kind of sketchy. So they are trying to make something like this, but it will be big. It will be bigger than Mir, but it will be lower than ISS. So that's in progress. Now many of you will be like, okay, what about private space systems? There are many space tourism concepts and things of that nature. However, I cannot put my money on it. Basically it's very pipe dream kind of feel to it. It's like we're gonna make a station and then tourists gonna go. It's like, what is your ticket cost? Like, what is your ticket cost? And if two people started doing that, both of them will be screwed, because they both to make sure they get their money worth, enough tourist has to go there, and to make sure that there is no competition, you have to do that, because if you start competing at that early stage, both of them will run out of money. So, and there are some interesting concepts that can have multiple layers of advantage, like this I practically like the idea. I will link the description down below. It's a deep space gateway, basically deep space. It's not like a lunar orbit. Basically it's a spinning habitat. Now the benefit of that, it's gonna spin slowly, so it has inner ring that is gonna spin at the same rate that it will give you gravity that is equal to moon gravity, lunar gravity, and there is an outer ring that will be constructed afterwards that will give us Mars gravity. Benefit of that is like, we will figure out, is lunar gravity enough for humans for long term? Yes or no? How do we gonna do the training? We can do the training here. Mars mission, this is absolutely key. So that may actually get constructed because it has multiple advantages. Other space concepts that I've seen is like basically tourism. That's not big enough. So in the future, LOB-G is guaranteed to be to be built. Chinese space station will be built sooner or later, and private station, let's see. So this was my presentation on space station. Hopefully you after this video you would have understand why we had to do it, and I hope you liked it or learned from it. In that case, please leave a like. If you didn't, don't worry about it, you can dislike it. I would urge you to leave a comment on my video, what you want to see in the next Rocket Monday episode, and please share amongst your friends, #S2T, and subscribe. Press the bell icon if you're free, and as always, thanks for watching.